All right, so I'll invite up our final speaker. Alex Margolis is a subject matter expert at Edaptive Computing. He is the lead developer for ECI AWESOME, which I think is mainly what he's going to talk about today, doing machine learning even when you're not an analyst, so bringing this to the subject matter experts that we also need to involve in this process. We've heard about that multiple times here as well. He's also developed ECI SEAMLESS, so looking at vulnerabilities and limitations of these models as well. So thank you very much.
Thank you. All right, so just for those of you who aren't familiar with ECI, we're a systems integrator with 27 years working with all sections of the DoD as well as private contractors to build complex systems that optimize, assure, automate, and integrate. So today I just want to talk to you a bit about bringing AI/ML to the average user, someone who is not an analyst, who has all this data, often subject matter experts who are very familiar with what they're testing or what their system is capable of, but don't necessarily know how to look at all that data and perform AI/ML. They may not be coders. So there's 4 key parts that we've identified as barriers for entry into the AI/ML world, those being use case selection, data quality and availability, the lack of educational resources, and then practical and logistical limitations. So the first thing we come into when people say that they need to perform AI/ML is, what do you need it for? What is your use case? So often that can be, we have all this data and we know we need to analyze it. They may not have a goal in mind, so we need to inform them on what can it do and what can't it do. And you have to be very upfront about that and say, AI/ML is not this magic box that can do everything perfectly. Got to kind of curtail those expectations, let it know here's what it can do. So there's things like unsupervised learning. If they don't have any training data, what can it do? So there's often big data that needs to be visualized, dimensionality reduction, and also data reduction. That's probably the most common question we get from users is, how can we have all of this data? We have tons and tons of data, and I just want to know, what's the relevant parts of the data? How can we reduce it so that we don't have to look through so much and spend so much time analyzing this stuff? And then anomaly detection, finding, if you have 1,000 simulations, which are the ones that I want to have someone who is a subject matter expert who can look at that simulation and see what exactly happened in it, but they don't know which of these hundreds of simulations they need to look at. So that's a very common one as well. So that's unsupervised learning, where they don't have labeled data, and then supervised learning, if they do, things like classification, forecasting, your prediction, content generation, computer vision, diagnostics, attack detection being if there's some kind of malicious attack going on with network data, for example, being able to identify that, classify malicious users. So we need to educate them on what it can do, what it can't do, and then help them make their selection. The next big thing, especially with DoD, is data quality and availability. Limited access to data sets is still a huge problem within the DoD. Everything is siloed. It's very difficult to get it where it needs to be for these tools. So in a lot of cases, the tools exist, but users can't get to the data. There's a lot of cloud solutions up there that can do all this AI/ML automatically, but you can't just take classified data and put it on to AWS unless it's goes through a lot of steps. So helping to alleviate that by making sure that we can get access to the data is a big step, and then making sure that that data can be properly handled. The data may also be sparse or incomplete. Often they'll be missing data points where we can either interpolate what that data point should be, what the missing values are. Often tests will change over the years, where we used to test on this and now we have these test reports, and then over the years they change, and older test reports may not have all the data that you're looking for. And so you have to be able to find a way that you can deal with that missing data and still create a good model. Data sensitivity and privacy concerns. This would be any kind of PII often there are all these rules and regulations on what information can be and cannot be included. So handling that can often be a big source of concern for users, because you can't just handle all data the same if it has sensitive data. And so there's a lot of different regulations and codes that we need to follow, and we need to make sure that any kind of AutoML tool that we're going to provide to users can automatically do that and make sure that they're compliant. Label data availability. This is another one. A lot of users want the supervised learning that we saw, all those use cases. They're very useful, but they don't often have the data availability. So how do you get that? And that's one thing that we can manually do, but also we can provide tools that can do it. Things like we've been asked to look at different surveys and find, what are the common topics on this, and classify how often these different things are of concern, but they don't necessarily even know what the common topics are. So then you can do some things like, okay, identify what are the common topics in free-form answers within a survey. Once you do that, label a small amount of data, perform classification, and then using that those preliminary results, create a better classifier, so you can iteratively go through the process, continue retraining your classifier until you get something that is a solid classifier. And then data security risks. Again, with classified data, you have to make sure that all of this is handled properly, that it's maintaining, it's labeling, that it's being encrypted at rest, all those kind of regulations that users, even analysts who are familiar with all of these algorithms, may not be familiar with all the processes and procedures that are required to run on secure networks. And then bias and representativeness. This can kind of mean two different things. One is bias as in your machine learning model may be biased, where you have a test set that is different than your real world training set. And so in that case, we need to make sure that our populations are the same. So we provide tools that will let you look at different data sets and see whether they are from the same population. But then bias can also be, especially when you're dealing with data about individuals, can be things like racial disparity. And so we need to make sure that these machine learning models aren't just callously looking at things and then discriminating against protected groups or anything like that. So making sure that your models aren't biased. And there's a few things that we can do that. Things like data profiling, just examining the data for biases, and then performing bias detection algorithms, visualizing the different biases that could be in the data, and then performing data augmentation. So if you have, say you're trying to train a classifier and you have something that's got a lot of classes and a lot of examples of one class but only a few of another, being able to augment that data, perform algorithms like SMOTE to generate synthetic data and augment your data. These are all things that data scientists may know, but your average user is not going to be able to do that. So you need to be able to look at the data, point it out to them, and suggest that these steps be taken. The other big thing with analysts especially is how much time it takes for pre-processing. Often you'll spend more time pre-processing than actually working on the algorithms themselves. So we want to have a tool that can handle a lot of that, especially with users who are not familiar with any of the pre-processing steps. So handling missing data, like we said, being able to interpolate missing values within data, or throw out data points if they need to be thrown out. Scaling normalization, if you have data from sensors where one of the sensors is measuring in millimeters and the other one is measuring in decibels, it's really hard to kind of deal with that unless you have some kind of scaling and normalization. So that needs to automatically be done without them understanding what scaling normalization is. But you also, if you are an expert, need to be able to go in there and choose exactly how that transformation will take place, again, with no code. Categorical variable encoding, being anytime that you have categories, you need to use some kind of method like a one-hot encoder to transform that data so that it can be used by these algorithms. Again, this needs to be done without the need for any kind of coding. Outlier detection and handling. And that's something that we can talk to the user about and ask them questions since they're subject matter experts. Can we throw out these outliers? Can we just filter them out and say, okay, before it goes into the model, we're filtering the outliers because we know that's going to be effective? Or are those outliers very critical and the model needs to be able to handle them very well? And that's something that the subject matter experts, they understand, and the algorithm may automatically not. So it's something that you really have to keep that communication open with. Make sure that we're discussing prior to building any kind of machine learning pipeline. Feature transformation and combination. So things like principal component analysis, where we can reduce the dimensionality of the data, identify key features, reduce unnecessary features, and then combine those to create aggregate features. And doing all that is something that generally people, your analysts may play around with and try different things, but this is something that a tool needs to be able to support as well as feature selection, being able to explain to the user which features are relevant and deal with high dimensional data, where you have things where they're one-to-N relationships or end-to-end relationships, being able to take those from data sets and analyze them. And then also identifying correlation and redundancy within the data. There's different techniques that you can do to give a number to the correlation and then let the user know so they can see within their data which variables are correlated and how, and then minimize redundancy. Next thing, lack of educational resources. There are a lot of educational resources out there that can help you become a machine learning expert, but not everyone wants to become a machine learning expert, especially if they're a subject matter expert out in the field. So we would need user-friendly resources that people want to use. So these would be things like tutorials on how to use a tool, your proper documentation so that users can understand it whenever they have issues, but then also interactive walkthroughs of the tools and demonstrations. And one of the things that we really subscribe to is that we should be educating the user as they're using it. They need to understand why they're making these decisions, what algorithm it's choosing, why it's doing that, what all the steps are. And so make sure we have tooltips on all the pages so that they can see what's going on here, and they can be informed as to how exactly this is working, even if they don't know necessarily how to code it up. And so we want to make sure that we're training them so they become part analysts, even though they don't need to actually know how to write all the Python code and everything. The other thing, tuning and optimization assistance. So a lot of these algorithms have lots and lots of hyperparameters, and tuning them is not necessarily a linear time complexity thing, since you have multiple hyperparameters. So it can be very time consuming to optimize these. Often, even experts will just have to kind of take stabs at them and see, what happens if I change the learning rate, and then see how that affects performances. But you can also look at the data and see, based on the data and based on information that the subject matter expert may know, things like if you're using a neural network, which activation functions you should use. You can kind of look at the data and perform some algorithms, perform Bayesian searches to optimize hyperparameters in ways other than grid searches, which can take a long time. But if time is not a factor, we can perform grid searches to just automatically tune these hyperparameters and get the best model for a given data set. Interoperability of models and explainability of predictions. So things like neural networks are going to be inherently very complex and very difficult to explain. And so with that, there are some tools that we can use to explain the models. Things like importance analysis, your sensitivity analysis, partial dependency plots, and model-specific techniques for each of these algorithms, if they have ways that particular algorithm can be visualized to explain why it's making the decisions it is. And this is something that kind of goes back to the very first bit of the use case selection and model selection of what is your requirements for explainability. And that's something that we need to be upfront with the user who's a subject matter expert. If you need something, we've had a legal department that needed to identify things, but it needs to know exactly why it made that choice. down to the T, that they can go in there in front of a court and say, here's the reason that we chose to make this decision. And so in that case, it may be something that's not some complex AI/ML model. It may be that we need to just build a decision tree in that case. That way we can have that exact traceability. In other cases, they're okay with the black box where we can't say anything about it. We just tell you what the best results were. So having both those tools where you can choose different algorithms, or if it is something that is less explainable, having the way that you can give some kind of visualization using those techniques. The visual representation of the results. When these things come out and it performs the analysis, how do we see what the results were? So that can be the form of charts and graphs, but also interoperability with other programs. One of the big pitfalls of AutoML tools, which is kind of what we're talking about here, of bringing AI/ML to average users where you're going to have no code. One of the pitfalls of them is often users will use them, they'll get their results, and then they'll not understand them. They won't know, is this accurate, is it not accurate, what's it actually telling me about my data? And so we need to explain each of those factors. So if we're telling them, okay, it has some accuracy, some precision, recall, and F1 score, what do those mean? What is a good value? What's a bad value for those? How do they know that their model is correct and accurate? And then feedback mechanisms. Users, as they utilize the tool, need to be able to give feedback, but also the algorithms themselves need to be able to receive feedback. So as users use it and they see the results, any corrections that they're going to do need to be fed back into the model so that it can be retrained, so that we can constantly have this iterative approach where the models are getting better and better. Last thing would be practical and logistical limitations. So these are kind of the things that can sometimes become roadblocks. One being data transfer and integration challenges. Being able to get the data to the tools and the tools to the data becomes a big issue, which is why we need systems integrators like ECI that we can make sure that those barriers are reduced, but also integrating with other tools. And we'll get into that here in a second. Resource intensiveness. This can be a big issue where a lot of these neural networks, in order to train, need high-powered graphics cards, often distributed processing. And in the case of a neural network like that, you may need that. However, there's also cases where you're on the edge of combat and you need this to run on a single laptop, and we see that a lot. And so you have to be able to support both. Any framework's going to have to be able to run on an individual machine, but also run in a distributed cloud platform where it can utilize GPU optimization in order to perform these complex tasks, but you also need to be able to perform simpler tasks on a mobile device. Integration with existing workflows. People don't like to have to go to some other strange tool, utilize it, and then go back to what they're used to. So you need to make sure that we're integrating with all these tools. We have integration with tools like Calibra and Hadoop data stores, different visualization tools that users are already used to. So we want to make sure that we're not forcing them to change their workflows and that we can integrate with these existing workflows. But the other thing is creation of new workflows. The way that things were done in the past by a human may be the reason that a current workflow exists, but we need to now actually do away with that and have a new workflow as we transform data using AI/ML. We need to not just stick with things because they've always been done that way, but also change the way that we think about these processes, because with AI/ML, it doesn't work the same as humans, so your processes may not be the same as humans. And then verification and testing. We've kind of, a lot of speakers in this conference have talked about, there's still an open question on how exactly we verify and test these things. So we need to provide the tools that we can. So that can be things like accuracy, but also different attacks that can be done. So things like data poisoning. Does can we verify that this is going to stand up to data poisoning? Well, we can figure that out by measuring accuracy metrics and then performing data poisoning and then automatically running them again to see whether there was an effect on that. Same with adversarial examples. So being able to verify and test automatically. So these are the kind of challenges that we see. With that, we've developed this framework called ECI AWESOME, which is we worked with the DOT&E to develop it. Here's the basic use case here. First, the user defines their analysis goals. They do this with a TurboTax-like wizard where they say, here's what my goal is, then answer questions about their data sets. So things like, does it have a lot of outliers? Is it important that those be included, or do you want to filter them out before we perform the analysis? Different questions about their data set, sensitivity, and then based on different goals, you'll be asked different questions. Where if you answer that you're performing NLP, it'll ask you, does it need to perform conform to certain standards? And each of these questions within the wizard has tooltips that explain what each answer means and why you should choose this answer versus the other one, so that users can understand how best to proceed. Once that, they can specify their data sets. We support CSV files as well as multiple different databases that it can automatically connect to, but also third parties APIs. So any API that has a REST endpoint or a WebSocket endpoint that uses JSON, you can connect to it without the need for any code. It can all be done using the UI, where you can specify what the format of that JSON that's coming from the call coming in would be and what the call needs to look like, so we can retrieve that data. But also, these are all in blocks. You can kind of see in step 3 that the model that's generated has a workflow with all these blocks. So as we need to get new inputs, that's a big thing, is that data is going to live in different ways and different formats for basically every new user that comes on. So we can easily create a new input block that gets their data from wherever it needs to be and then puts it into the raw data format that can then be used for any of these algorithms. So we've got this step 3, generating an AI/ML model. There's a lot of different classification, clustering, prediction, track to truth, matching, image analysis, and NLP that can be done as part of this toolkit. And so we, based on the toolkit, choose what the best algorithm is going to be. And you can see, like, we have the data, first get the data, then parse the CSV. So wherever that CSV came from in this case, it's going to parse the CSV. That could be a different block if it's from a database or something like that. Then perform pre-processing. And so these are the steps that can save a lot of time, even if you are a developer and you have your own algorithms. Because then the new algorithms can be brought into this toolkit, and then that way, as we get teams that have existing algorithms, or as we develop new algorithms, we can easily add those in and then automatically connect it to all the different data sources that the tool can use. And then you have your outputs. So in this case, it's going to evaluate how well your clustering performed and show a chart. That could also be going to a server or making an HTTP call where you can specify what the JSON of that call should look like, where it's going to go, if it's going to have any authorization, that kind of thing, so that we can send these results to where they need to go. And then step 4 is to execute it. This could be triggered manually by the user saying, I want to execute my model, or we can perform streaming data, where as things come in, we automatically execute the analysis on them, or we can do things like monitoring a directory, so that as simulations are saved, we automatically run the analysis on the simulation, get the results where they need to be, and then the user never has to use the UI at all. And these executions can be done locally on the user's machine or in the cloud, where we can have parallel processing and GPU optimization and all that. Either way can be performed. And then kind of touched on this before, but the real-time analytics are reported via a dashboard and a web tool. It can also generate reports, so your traditional Word and PowerPoint reports can be done, as well as integration with additional tools. So ECI also helps bridge that gap between subject matter experts and AI/ML, allowing them to quickly build models and in a graphical environment and execute them with ease. So this was developed through CIBR programs as well as with DoD, which means that there's no license at all for government use, and it's built with DoD use cases in mind. The framework is rapidly expanding as we add new algorithms, and it should be deployed on Dista Cloud for anyone that has a CAC that wants to give it a whirl here in the near future. And anyone who's interested in seeing a demonstration or learning more, please see me afterwards and we can arrange something. But any questions?
Okay, a couple questions. So when I see these like GUI approaches towards like AI, ML, I'm always skeptical because everyone's data is idiosyncratic. There's always some very unique thing going on with the data. And I kind of assume that that's why we have code, because it's custom built to the data set. So I guess I have two questions. That would be my first one. Like, what is it? How do you see this being implemented? What kind of use cases? And like, what would you be doing to try to, like, are you trying to address that? Or are you saying like, this kind of data is expected to be like less idiosyncratic and that's just what our application is?
So yeah, it's a combination. One is there are many data sets where it works out of the box, where there's no special idiosyncrasies. You just get there and you select, here's the columns that I care about, here's the ones that I want to ignore, and here's what I want to find out. But other cases where you do have those things where you need to perform more advanced pre-processing. And so in that case, we do work with users to create something that's going to be specific for their data. But the advantage here being that even if we have to create something that's going to be specific for your data for getting it in, or to pre-process it and get the correct features that need to go in the model, then you have this suite of all the different models that can then be utilized on that with minimal code. But yeah, there's some times where you do have to write code, especially in the pre-processing step to handle that data. And so that's something that we run into. We had multiple users that needed to perform track to truth, but they have very different data sets, and they have different things where there's no headers on this file, and you just need to know this kind of thing. And so we have to build custom inputs for them. So.
Okay, great. Yeah, that helps. And then my other question is that, are you imagining this would be used mainly for EDA, like exploratory data analysis, or are you thinking like this would go into deployment in an app and have interactivity with users?
So there's some of both. EDA would be the biggest use case, would be kind of starting it off, finding out what this can do, and then it can be deployed. Once the model is built using this, you have your actual machine learning model that can then be deployed and hardened and made into a more enterprise product. Yeah.
Okay, and then would they have to like pay you a subscription for that, or how would that work?
Yeah, so any of the customizations they have to pay for, but anything that's out of the box, it's all free in perpetuity for government only. Yeah.
Okay, thank you.
Yeah.
It's on. All right. So, the no code options for AI and ML are really interesting. Sort of related to things that we've seen in the past. And if we think about, for example, linear regression, we've known about linear regression for a couple hundred years.
Yeah.
It's from that perspective, it's taken a long time to get to the point where you can run a linear regression with a single line of code or by point and click, which you can now do in many popular software programs. We've been able to do that for a couple of decades. But there's been this long time lag for that transition, where in the meantime, the research community has served as a buffer toward responsible use of those types of statistical algorithms. Not fully buffering it, but sort of serving as a buffer there. The thing that's been interesting in my mind about these no-code solutions is the speed with which they're being developed and deployed. It's all happened very fast. And I'm wondering if you can comment on that, the speed of development of these no-code solutions to something that's very complex from the standpoint of ensuring responsible use of the underlying technology.
It's really, really good question, and it's a good point. Once we have this framework of we can build you a model with no code and you can do it, I think to your point of these algorithms, especially with, for instance, the LLM space, are rapidly changing, and so we don't know necessarily what the limitations of them are. And so when we are deploying these things where someone doesn't even need to code, and so they really don't understand what the algorithm is doing, what its limitations are, we have to make sure that we really educate them and let them know, here are the known limitations of this algorithm and of your results. And as we display all the results and the metric and the verification, the testing results, showing them, here's what we know the limitations are. But then we also have to do a job of educating them of, there are a lot of unknowns where we don't know what the limitations are. We don't know what can go wrong, and we need to make it know that there are unknown knowns and unknown, or known unknowns and known knowns. And so we know what some limitations are. We don't know what some are. Where the AIML space is just expanding way too fast, and things are getting deployed way too fast to understand all the limitations of that. So we can do our best to educate them, but we also just need to educate them that we don't know the answers to these. And as long as you're upfront with that and they understand the risks and that they plan for those risks, I think that's okay. But yeah, the risks need to be tracked, and the fact that we don't know the risks also needs to be tracked. Yeah.
All right, thank you.